In this question, we are going to have to state the domain and range of a given piecewise function and then graph it. It's phrased this way in this order, but for the most part, when you're getting started, it's going to be easier if you graph it first, then state the domain and range. Because finding the domain and range is a little bit easier to see from a graph than it is from a function until you've got a lot of practice with it. So I'm going to start by graphing. I'm going to think of this as two separate functions for a second, a red one and a green one, just to make sure we are seeing on the graph what I'm talking about. So for this red graph, 2/3 x plus 2/3 if x is greater than 2. So I'm basically saying all this stuff over here, I'm going to ignore for just a second. Now, this doesn't let me just put on the y-intercept and count out slope, which is kind of annoying. So what I'm going to do is I'm going to look at this value, 2. I know that it says x is greater than 2, meaning I'm going to have an open circle, but I'm going to plug in that value because that's the first thing that I would actually get to look at. So if I do that, I'm going to have 2/3 times 2 plus 2/3. Well, 2/3 times 2 is 4/3 plus 2/3 is 6/3, which is 2. So at x equals 2, I have a y value of 2. But again, this is an open circle because I don't actually technically get to have a value at x equals 2 in that red piece. But this is where it would be if I had one. So now, from that spot, I can count out my slope. So up 2, right 3. Connect the dots with my arrow because I'm getting bigger than 2, so I keep going to the right. Okay, now I'm half done. Now to the green one, well, this one should be very easy. I'm still going to start at x equals 2 because this time I will have a closed circle. And when x is 2, that becomes -2 plus 1, which is -1. Then I'm going to go -1 for a slope, but since I'm going to the left of 2, x is less than or equal to 2, I'm going to go up 1, left 1. I can put as many dots as I want, but I should be going through my y-intercept of y equals 1. I have my arrow going that way. That is my graph. Now, if I have the graph, it should be easier to find the domain and the range. For the domain, it's all of the x values that I can have. Well, because we had all values of x less than or equal to 2 and all values of x greater than 2, I can say x is an element of the real numbers. Any x value is going to work. The trickier one is the range. What possible y values are there? Y is going to be an element of the real numbers such that this is where we actually have a restriction. If we look at our graph, the lowest possible y value we get is -1. Everything else is above that value. So I'm going to say y has to be greater than or equal to -1. Because there's no way for me to get x equals -10, for example, as long as I'm following these x equals less than or equal to 2, x is greater than 2 restrictions. Right? If I put in x equals 9 into that green part, sure, I'll get something small, but I'm not supposed to be getting that because I would actually have been in the red part. As you get more and more practice with these, you are going to be able to kind of look at the function part and start to figure out what your domain should be before you graph. That's actually the way I personally do it most of the time, just because I don't have to find as many exact numbers for domain and range, and so I can kind of narrow down what my graph should look like. But as you're getting used to this, graphing it first is always going to be the best option. All right, have a great day, everybody.